Okay, another falling object on a different planet this time. You'll notice if you do questions like this a lot that on Earth, for things that don't have wings or parachutes or engines on them, the S function is always going to be minus 4.9 t squared plus something or other. And this 4.9 is a property of the planet. It's how strong our surface gravity field is. This is a different planet, and that means they're now free to make up a different number for this, and they've chosen minus 3.2. So, okay, things don't fall as fast on this planet. But math and physics still work the same way, so our procedure isn't really going to change all that much. We have this object. It's up on a 70-foot something, building or top of a cliff, which is 70 meters high. And this 2.5, you'll see in a minute, tells us that the object starts with 2.5 meter per second upward velocity, because that's positive. So somebody threw this object up, it rises for a bit, gravity gets a hold of it, and down it comes. Falling, 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 thump. And right about there it hits the ground. And they say determine the time it would take for the object to reach the ground. Well, if we know its height is minus 3.2 t squared plus 2.5 t plus 70. When you're on the ground, your height is 0, so there we are. As usual, because I'm neurotic about leading negatives, I'm going to multiply all this by negative 1 minus 2.5t minus 70 equals 0. And now we can use the quadratic formula to find the solutions to this. As in a previous example that we've seen, this is going to give us a negative solution, which doesn't interest me. That's before the object was actually thrown. So I'm only going to do the plus part of this formula, and it's minus b plus or minus, but I'm only doing the plus as just explained, b squared minus 4 times a times c. I'm writing positive 70 and changing this to a plus to avoid the double negative thing. All over 2 times a is 6.4. And if I can avoid throwing my calculator all over the place, 6.25 plus 4 times 3.2 times 70 equals square root plus 2.5, and all that divided by 6.4. I get that the time is 5.08 seconds. So that takes care of A. We got a sketch, and we have a time to the ground of 5.08 seconds. What is the object's velocity at 1.5 seconds? Well, if we're doing velocity, we need a derivative. Velocity is the first derivative of position, the first time derivative of position. And so you get it by doing 2 times minus 3.2 is minus 6.4 t to the 1 plus 2.5. Now, that means the velocity starts out at plus 2.5, as mentioned before, and then it goes down by 6.4 every second. That's because gravity starts pulling you downward, and if you are going downward, makes you go down faster and faster. So if it's been 1.5 seconds, we can say if t is 1.5, then our velocity is minus 6.4 times 1.5 plus 2.5. And if I'm not mistaken, that comes out to minus 7.1 meters per second. What is the maximum speed? Well, in theory, there's no maximum because an object could fall forever, but here a little thing called the ground interferes and only lets you fall for 5.08 seconds. So how fast are we going after that? 5.08. We just run our velocity thing again. Minus 6.4 times, we've been falling for just over 5 seconds. We always have our 2.5 that we started with. And 5.08 plus 2.5, I get minus 30.0 meters per second. That's how fast this object's going when it hits the ground. And what is the acceleration due to gravity on this planet? The acceleration is the derivative of velocity. So we can find that without too much trouble. Acceleration is the derivative of velocity, or the second derivative of s. It's 1 times minus 6.4 t to the 0, and then this term's just gone. So minus 6.4 meters per second squared. Earth is 9.8, the moon is about 1.6, 1.7, Mars is right around 4, I believe. So this planet is smaller than Earth, but not that much smaller.